Two centimetres further from the lens than where they are. But we don't know where they are.
Don't know yet.
No.
Well, we need to
Yes,
know
but we've got a focal point so we can work it
right
out.
now. There is no real virtual space.
Because
Us
DI
what we do
equals
is
DI
instead,
plus 2.
not where the image would be.
So, see,
So
there's
we
one.
ignore the image and the real and virtual.
Yeah, that'd be an excellent level question. Go on.
Oh, well, that is it.
Go for it.
Provide like a giddy answer.
Just one question for the day. Just one.
Just look at right here.
Oh yeah.
And then one, you guys do that. Is it something like x equals?
Yeah.
Who's trying blasting tunes?
How do you plus it?
That's where I can hear your whole music from here.
Is that right?
I can hear it as well.
Well, what do you ask me?
Who's got their maths book here? Is that right?
What is it?
Well,
What is it?
whether I had my math book or not, I don't know.
That's gonna help.
Ah. Someone Google quadratic formula and see if that's right.
The quadratic equation.
Quadratic formula for what?
That doesn't help us.
Get yourself in and Google it, see if I can remember it right.
No way, we
School's
don't
Wi-Fi
do
doesn't
it.
work very well.
What?
Yeah, we couldn't do online classes at school because the school's Wi-Fi.
Minus 2.
No, you just go over
It's not personal problem
Yeah,
for the
but
school.
like, it is negative 5.
Why is it the schools? Why is it bad?
No, because
No, it's actually
Yeah,
alright.
right.
Negative 5 though.
Yeah, the
Yes,
school's
I know
Wi-Fi's
it's
bad.
5,
The one's
but
mine.
like, it's really
What you about to say?
So that's
No.
it's
God, yours is bad.
B squared minus 4. So minus b squared minus 4.
You tell me this, Ed. Yeah? How do you add plus 2 and no?
That's virtual.
Like that? Is that right?
How do you add
Can you
that
just
in
combine
there?
it? Can you just go
not concave.
DO plus 2?
Yeah, still look at that.
No. You can't.
And maybe we just plus 2
Jesus
that DO. That's 3 over DO plus 2.
Something that's
So you have to do it the other side equation.
Or it's not that by that and that by that.
Just move DO plus 2 over.
It sounds like this might be a case of the physics class teaching you maths rather than the maths class teaching you physics.
They kind of do work together.
They kind of are the same.
Oh, yeah.
So,
you do.
I think you're going to end up with a quadratic equation when you do this one, and if you end up with an equation that's ax squared plus bx plus c, that's quadratics, right? X squared, x, and some number, then you can use that equation and it will give you the answer.
That equation.
That one.
What even is that equation?
That's the quadratic formula. You just plug the numbers in and it gives you the answer.
Sometimes you're gonna be
Yeah.
So we'll spend maximum 10 minutes on this, and then we're going to move on to our refraction work.
still one on the top.
But you're going to show us how to do this, right?
You're going to times it
Come on, help you. Start. Where do
Oh,
you
you
start?
need both those numbers.
I don't even know where to start.
This one would be like that.
Times, because this is
Okay. If you're not sure where to start, start with.
plus 2 over.
It'd be like that.
Oh, me. Yeah.
Start with your mirror lens equation if you're not sure where to start.
Oh no.
This is important.
And then that
Oh, no, this
goes
one's
into
not.
this.
Yeah. So can you, then would you just go to the
2 0 plus 6.
Oh, do you just...
A common denominator.
Well, if he wants us to get that, he must do that.
Yeah, done that.
Yeah, but we didn't get what he wanted.
okay.
Aiden, did you get a quadratic?
We'll start with that one.
First the time you come back,
We'll start with like 2 equations and 2 unknowns. We've got the DO, x is DO.
That's one. You change it by 5.
equations.
The sums of different components by zero.
Oh, quadratic.
Well, we did that first, and then we got to here.
Oh, we didn't times the
You didn't
To
put
times
on that.
it is a 0. But if he wants quadratic, we do
Multiplying the top and the bottom of both fractions by the sum of the other fraction.
So it would be like,
So you just multiply this fraction top and bottom by do, and this fraction top and bottom by do. And that way you end up with two fractions that both have the same denominator.
But then,
then
yeah, you can.
plus them.
times by d.
So then it's just 5 do plus.
No, it's
Yeah.
d equals
Pluses do 2 adds to the plus.
What are you, where are you at?
Nothing.
yeah, you don't have to times it to one side. You don't have to do it to both.
Okay,
So
there
you
we go.
get that as one.
Then
Is it
we-
pluses to 2 and adds to negative 5?
What?
Times the negative 5.
Yeah, they would perfectly speak. So when you times, yeah, when you times by d plus 2, you check. Yeah.
If you go do
That means
plus,
that it's 2d plus 2.
if you go times do plus 2 equals 5 do.
Together, since they have the same denominator. 2d plus 2, right? So 1 over 5.
No,
How can it is?
Plus these together.
Can it is something?
Yeah, you're on the
So we have to make this
no, you just.
that one is there up here.
Refraction.
What does that mean?
Does that mean?
Which is essentially just the 5 that's the driver. And then, yeah, you can go under.
What do you do?
It'll be 2d
You just,
plus 2 on the bottom.
times it by d, so that is times that you just.
Because look, if you times both of them, right?
Yeah.
But then you have to
How do you
times.
times fractions again?
that by-
Do you do them as a
You have to
Times
substitute
in
in.
fractions, son?
At this stage you don't know what di is, but you know it's do plus 2.
Times
They
the
just
So
times
here you
top by
put in
top,
do
bottom
plus
by
2.
Yeah.
Oh, I didn't see that,
Times
EG.
fraction, sure.
I think
Nah, it's Baraka.
Yeah, I know, but.
I don't understand the question. What is
Maybe I
that?
do need, maybe I really do need to rub out Mister.
What's they?
Where the dude is.
Oh, okay.
Randomly got.
Calculate where he should stand so that an image forms 2 centimeters further from the lens than where he already is.
Yeah, so wherever he is,
There
the
should be
image
something
is
behind.
2 centimeters further on the other side. It's awkward wording of a question that's going to
Okay.
make it really
No, but
awful.
it's a plus.
Okay,
You can't,
sweet.
you can't equal just times.
When we, sorry, it's a bit small, but
You
when
don't.
you multiply fractions by top by top,
So there's a few different ways to do it. If you're
Yeah,
going
let's
to
go
be
here.
able to add
You
them,
times
you have to
everything
end
by
up with them
5,
both
and you
having the
times
same
everything by
bottom.
d, and
Yeah.
you times everything by d plus 2.
Yeah, I'm just gonna try this one.
yes, but if I
Times
want to
by d,
multiply
that's.
the two denominators, it would give me, would it give me 2d squared or 2d plus 2 squared?
2d squared.
Okay, and then plus 2. Because that's what's on the
It
bottom.
would have, so you're multiplying do times by do plus 2, so you'd have do squared plus 2do.
It goes back to the
Yeah,
thing.
I'm going to go through it on the board. Sorry, Mister.
That's a whole bunch of d. That's all I get from that. Like that.
Okay, so children, let's, I can see that a few of you are like completely, some of you, you're getting into some good quadratics, but then there's a few like stumbles along the way, so let's just see if we can puzzle it through together. I think I've seen at least 2 different ways of doing it, so I might have a go at doing it the 2 different ways just to empower everyone. Because there's nothing worse than when the teacher does it like the other way, right? Your way's like it's the other way. That's really, let's try to avoid that. So we've got 1 over f, both ways. 1 over f is 1 over do plus 1 over di. And in both cases, we recognise that di is do plus 2. So instead of writing di, we're going to write do plus 2. And so we end up with this problem that we've got 2 fractions that are added together that don't have the same denominator. And so we can't do that. And so there's a couple of different attack strategies here. The first one is to try and make them have the same denominator. When you've got two denominators that are different, the sure way of getting the same denominator is to multiply them together. So if you do that, you're always going to get a common denominator. So if we multiply do times do plus 2, we get do squared plus 2do. So one attack strategy is to go 1 over f equals we're going to multiply the top and the bottom of this fraction by the other denominator. To keep it, we have to multiply it by the same on the top and the bottom, otherwise we're changing the fraction because we're multiplying it by something that's not 1. So what we're doing is 1 over do times by do plus 2 over do plus 2. See how that's just multiplying it by 1? And then we're doing the other fraction, this one here, we're doing 1 over do plus 2. We're multiplying that by do over do. And that's going to get both fractions to have the same denominator. So just like this fraction here has turned into all of that, and that fraction there has turned into all of that. And so let's evaluate that. So do plus 2 over do squared plus 2do plus do over do squared plus 2do. Look, common denominator. Now we can add those together. 1 over f equals do plus 2 plus do over do squared plus 2do. That top line, what does it actually look like? 2do plus 2 equals 2do plus 2 over do squared plus 2do. And so now we are going to get this bottom part of the fraction and multiply it up to the top of the other side. So we're going to, and the f is going to multiply up to here. So we're going to multiply the bottoms across to get rid of any fractionality about this at all. So we're going to end up with 1 times by the do squared thing, do squared plus 2do equals the f times by that, 2do plus 2 f. So the f is multiplying up. We could put brackets and put the f outside, but we'll just do the whole lot at once. And we know what f is. F is 5. So let's put that f as 5 in. So do squared plus 2do equals 10 do, because 2 times 5, plus 10. Now we want to get it into this form here. We want to make it equals to 0 so that we can kill it. So, do squared negative 8 do
Minus 10.
equals 0. And so we're looking for two numbers that we can add together to get negative 8, or multiply together to get negative 10. Sometimes we can solve these ones just using our brains. Can we solve this one using our brains?
I tried.
You tried, you couldn't get it? Two numbers that add to 8. And so it must be one positive and one negative,
10 and negative 2.
Yeah.
It has to be one positive and one negative.
Negative 10
Negative
and 2.
times it, so
But
you
that
gotta
doesn't
multiply
add
it,
to-
it's a negative 10.
Doesn't add to
And a
negative 10.
negative times a negative.
Oh,
I mean
it's
times the negative 10.
Okay.
Oh, you're
And
right.
so this is where the beauty of this maths comes in. When we get one that we can't do, we use this thing, the quadratic formula, and I'm sure that Buddha's going to teach you this, or Mr. Edmondson, or Miss Ford, but we're gonna plug our numbers into there. We're going to use that equation to get the answer. And so we're going to solve it.
That's crazy.
Because we've got here, it's like x squared minus 8x minus 10 equals 0. And like maths lingo, A.
Yeah.
So how much is A?
8.
How much is B? And how much is C?
A is 1, B is negative 8,
Yeah, it's
and C is negative 10.
Good. And so we're going to plug those numbers exactly into that equation there. So x equals negative 2 times negative 8 plus or minus square root of negative 8 squared minus 4 times 1 times negative 10 over 2 times 1. Let's just try and simplify that a little bit. X equals negative 2 times negative 8. 16 plus or minus negative 8 squared.
64.
64. What about 4 times 1 times 10?
That's negative 4, isn't it?
Okay, negative 4 times 1 times negative 10 then.
40.
40. 64 plus 40?
104.
104. So we got 16 plus or minus the square root of 104 over 2. How much is the square root of 104? Who's got their calculator? 10, roughly, right? Should we call it 10?
No.
Not worry about it. Let's call it 10. I like 10. So we got x is equal to 16 plus or minus 10 over 2, which is the same as 8 plus or minus 5. And so x is equal to
Negative 8.
no 8 plus or minus 5. 3 or
13.
You mean DO equals 3 negative. I mean,
Oh, thanks.
so we could put our person, our dude, at f equals 3 or f di equals
DO.
do equals 3 or do equals 13, and either of those places would get us an image that was 2 centimetres further. It would make an image at 5 or 15.
Damn.
That's
Damn.
crazy.
That's kind of cool, eh?
Not really.
What are the chances that would be in the exam?
I've only once, and it was like back in 2004,
Oh,
seen
thanks.
a question that hard in NCEA. It was like one of the first years of NCEA. There was some question about a cat in front of a mirror, and you had to like kill it with quadratics. It was just brutal. I'm sure no one got it, but you can do it. Anyway, it's nice that now when Buddha shows you the quadratic equation, who's you guys' maths teacher?
Mr. Edmondson.
When Mr. Edmondson shows you, you'll be like, oh, old hats who have done that.
Easy. Easy. Okay, old heads.
Old hats, sir.
Cool. We're not going to mark homework today because I don't have a laptop here and it's just too complicated, so we'll do homework next time.
Yes.
What we are going to do though is reset up that diagram that we had in your notes yesterday, and we're going to work it through as an example. So if you want a photo of that, take a wee photo. But probably you'll be okay. Well,
If we're not, well, it's out.
how's the battery level looking on that? Do I need to plug it in?
No, it looks like it's full. It's got 3 white blocks inside the battery symbol.
I can rub it off.
Yeah.
So cringe. I'm sorry to upset.
So the main thing we're aiming to learn today is how to use that Snell's law thing. And so the one that we did yesterday, we had air and water and
Air and glass.
air and glass.
That was a dumb one. Oh, that's why when you put your finger in water, it works like.
Wait, does your finger like every time you put it over the
That looks like it does. You put it in and it's like.
yeah.
The speed of your finger changes when you put it in the water.
Wait. True though. It's true.
The speed.
It's true.
No.
Yes, there's no friction on the water.
What's the scale?
Oh, no,
Water
that's
is more
right. But
dense
that's
than
not
air.
why. That's
Yes,
not why.
yes, that's why I think it.
Resistance.
Do.
We're gonna be corona. Freeze one corona.
Glass.
Oh.
And so we had an angle. We didn't put any numbers on this, did we?
Not just an example.
Okay, so. But we did call this theta r
Yep.
angle of refraction, and we did call this theta I angle of incidence. And we did have Snell's law, we did have written down the n1 sine theta I equals n2 sine theta r. Is that roughly where we got to last time?
Yeah.
Yeah.
Okay, so, I reckon we can probably start recording from any time from now on, unless you already are.
Yeah, I'm still recording. Still recording from the last bit.
Oh, okay, cool. So the first thing that we're going to think about is that when you do the exam, this is the question that they often try and trick you on. Like, if there's one place they're going to try and trick you in the exam, it's in this question. And the way that they trick you is they tell you that angle down there. How much roughly does that angle look like?
45.
No, it's
60.
way more than 45.
60.
60? Let's call it 60 degrees. And what's the problem with that? Why is that a problem?
Not the angle.
It's not the angle of incidence. So how would we work out angle of incidence? If we know that-
from 90. Oh God.
Cool. So theta I is equal to 90 minus 60. Theta I is equal to
30.
30 degrees.
Good man.
And often in the exam they will give you that, and if you forget to do the minusing, it'll either not work, you'll get a math error, or you'll just get an achieve level instead of a merit level. So always on these questions, make sure that your angle is measured from the normal. It's the thing that they will try and trick you on. So then what we're going to do is look at this, and we're going to try and work out how can we work out angle of refraction. And it's complicated because it's an equation that we haven't seen before. It's got two different signs in it. And sine it's complicated. It's like when you sine something, you're not timesing sine by the angle. It's a function. It's like a sausage factory. And it's like when you put meat into the sausage machine and sausages come out the end. That's kind of what sine does. Like you put an angle into sine, and then like some number comes out the end. And so if we want to undo the sausage, it's like the same as a sausage machine, right? If you want to undo sausages, you put the sausages into the machine, you put it into reverse, and the meat comes out, right?
Is that possible?
The same, yeah, right. It's the same with the sine. Like we can't divide by sine,
Some children.
we can't minus sine. We've got to anti-sine. We've got to put the sine into reverse in order to get the angle to come back out of it. So bearing that in mind, finding
But it's in here.
theta r, we've
That's what he means.
got n1 sine theta I equals n2 sine theta r. We're going to try and rearrange this to make it theta r equals. What's the first thing we're going to do? Divide it by? What's the problem with dividing by n2 sine?
It's not a number.
Sine
It's a
theta.
sausage factory. You can't divide by a sausage factory.
Wait.
What can we divide by? Which one is a number? n2. So let's do that. Divide by n2, divide by n2, cancel, cancel, right? Normal maths. And so we just have to avoid falling into the trap of timesing or dividing by sine. So we end up with n1 sine theta I over n2 equals sine theta r. And it's at this stage that we have to think it's a sausage factory. The only way to get the meat back out of the sausages is to put it into reverse. The only way to kill sine is to do anti-sine instead. What is
Cos.
Sine
Tan.
-1.
sine?
Log.
Anti-sine. Anti-sine's a thing, right?
Oh,
We're on both sides of the
Sine's
equation.
the power of -1.
We're going to, not to the power of -1. It's anti-sine, it's different. It says -1, but that's just the symbol for anti-sine. It's not to the power of -1. Sine angle to the power of -1 is a whole different thing.
That's how you write it.
So, anti-sine of,
This took all
And-
of it.
anti-sine of,
crikey.
anti-sine kills sine. And so we end up
Then
with
there's no sine.
theta r equals sine anti-sine of n1 sine
Is that working?
theta I over n2.
Does the
Where?
anti-sign go in front of the brackets?
Yeah.
Is that how to write it?
Why
It's
didn't it go the first
anti-sine
time?
of, it's a sausage factory. What are we
Doesn't-
going to anti-sausage?
Just running how to write it properly.
But so you've taken it out of that one, but you wouldn't take it out of the other one?
No, it doesn't. It's a sausage factory.
Can you,
Why is this?
can you, anti-sausage factory in the calculator?
Keep the
Yeah,
text the
yeah.
same, so.
You go
Sine.
shift sausage factory.
What? That's crazy.
So let's have a go and see what this might look like.
Oh, I actually want a sausage right now.
So on your calculators, make sure that it's in degrees and not in radians, otherwise it's going to crash, can't it?
Oh, it's
No.
Yeah, that's right.
Just doesn't.
So this
Because,
one will do this one.
you can only anti-sine an angle. So when you sine some, so we think about what sine is. Like it's, what sine does is it goes from like 90, 180, negative 90, negative 180, that is 1, and that's negative 1. So when you push the sine button on your calculator, what you're doing is you're telling your calculator, look at that graph there, find out what the number is on that graph. So if you put in sine 60, say, it goes along to 60, up to where the graph is, and it's like, it's that much there. And so when we anti-sine, it's going to find that number on the graph, and it's going to go along and be like, that's how much the angle is. And so, over here, have I confused you?
What's it gonna be?
Is this the first time you've seen this?
Yeah, definitely.
Yes.
What did the sun
No.
Oh, well, you've done sign probably 10. But it was definitely wasn't like that.
It was like
Using it differently.
They just told
it was like
us.
adjacent and all that stuff.
Yeah.
Oh,
just
I
told
Sin
can't-
of the angle.
They just told us when to plug it in.
Yeah,
so
so,
Cartola.
but if you were to graph sine, if you were to put in like 1 degree, you'll find out that sine of 1 degree is like a very small number and 2 degrees is small. And once you get up to sine of 90 is exactly 1. And then if you go beyond 90, if you take the sine of like 91, it's a little bit less than 1, it comes down again. And when you get to sine of 180, try it on your calculator, it's 0.
So,
And this thing repeats, actually, it's a repeating graph. I've just drawn a tiny bit. It keeps going forever in each direction. Just up and down from never higher than +1 and never lower than -1. And so the important thing to know is that when you're pushing sine of an angle, you're just telling your calculator to find how much the y value is, because y is equal to sine x. You're saying find the y value for this angle, and it's always going to be between -1 and 1. And so when you anti-sine, you're saying, here's my y value, and you're telling your calculator to find how much is the x value. The complicated thing though, and this is a maths problem, not a physics problem, is that if you tell your calculator to find 0.8, it will give you the first one it gets to, but there's an awful lot of places on the sine graph that it's 0.8.
Is it infinite?
So the nice thing about sining an angle is if you put in an angle, there's only one place that'll only ever give you one value on the y, but if you put in a y answer, there's going to be an infinite number of different possible x values where that could occur. It will only ever give you the one that's closest to 0. So this is x equals 0 here, eh? It will give you the one that's closest to 0. That's a maths thing that you need to know. Money.
since sine is a function, and looking back when you anti-signed
Yeah.
over there, since there was n1 next to the sign, is that why you couldn't anti-sign it, because it was next to like a coefficient? Or
It just meant times, so it wouldn't really matter, would it?
Sine theta is a number. Sine theta, if we have to look at this
you can.
whole thing here, that's just a number. And so if we separated out that number and just anti-signed that number, we would get back the angle. But what we're doing is we're adjusting the value of sine theta by multiplying it by n1
okay.
and dividing it by n2, and then re-asking the question, how much is it now? And that will give us a new angle.
Okay. Yep.
So,
It's not a great answer to Tana's question, actually, but I have to think about that. We definitely don't. It definitely doesn't. Why? I can see that it's not clear. Why not? Yeah.
It simply doesn't.
Let me
So-
work on why not.
That's why.
so like I
Math, that's why.
It's because you've got it on, not on degrees.
How
Got
do
it
you
on
say
degrees,
it's
mate.
degrees?
Anyway, so we're here. We're at
Oh, shit.
at theta r equals anti-sine of. Let's make it too complicated because life is meant to be easy, right?
No.
Theta r is anti-sine of n1 1 times by sine of angle of incidence
30 degrees.
30 degrees divided by n2 1.5. Plug that into your calculator, see what you get. Should be less than 30.
19.47.
Alright, so all just have a go at plugging that into your calculator. Make sure that you can get 19.47. If you can't get 19.47, either means that Aiden's wrong or that
No, I got it as well. I got it.
That's
Unless
me.
we're both wrong.
right. So it's
I'll
looking
do it
like
then.
if you can't get it, you're wrong.
I need to put into the brain.
You got it yet?
Is it easy for
No, I'm waiting for Todd to get it.
Or is it
Do it on your calculator.
But I don't see it. I don't know how to use it.
It's the sign of the angle of incidence, and we know that it's
Angle, we don't want to measure the radians, we want to measure the degrees.
Yep.
Got to be that
Give
degree.
me that. No, give me that.
Now if you go sine 91.
That's very cool. But then I have to turn it back.
No,
Never.
not until year 13. Year 13 you might use radians, but in year 12 it's definitely just degrees.
Ethan isn't even that far away.
Cool, nice one.
No, you just used to be like, oh, I just did it with Ethan. That's like, it's next year. That's scary.
Yes, sir.
That's a good feature.
I drank piss.
How many decimal places do we do?
3 6
Hey,
feet, Todd.
type the whole thing in
3
as one.
I don't know, just
So you could go shift
19.5
sine
then.
bracket 1 times sine 30 over 1.
That point one really matters.
No, not
Does.
What point one?
The 19.471.
No, but
Bruh.
46 foot would be 19.4. Oh, 9.5.
Hang on, yeah. Yeah, be careful with that.
Yeah. Because the 1 and the 9.
That's
I got a key last time.
Where?
No, it's not.
Oh, I guess not.
Oh, you got refraction.
Oh, you got that funny calculator.
So I would put a double bracket rather than a single bracket.
You can't just
Or two double brackets.
refraction on this calculator. Then I can bracket that.
How do you do it?
Bracket.
You just
Oh,
can't.
no, get rid of that. I'm not bracket.
Oh, okay.
Thanks so much.
Yes, Mr. Sextant.
Well, how do you do it?
I don't know, you gotta do that.
What did you do? Yeah,
One
it's
times
easy
sine
by
30.
1.5.
I don't swim in the ball.
Divided by.
Swim in the ball.
Full on
Same answer.
The number you get is just degrees.
That and that and that.
You have to put.
Oh, that's what you do. Times by that.
You have to put.
And I got
Get it done.
the background on.
You don't actually have to
I
The degrees.
bet.
Oh, no, don't need degrees.
Oh, you don't.
Can I do it just like that?
Can I just interrupt because just going around, it reminded me that there's a couple of pitfalls with this. The first one is that it's very tempting. I think in maths they teach you to use the fraction key, but there are cases where the fraction key, when you're solving this problem, will give you the wrong answer. Better to use the divided by key with brackets. So if I were typing this into the calculator, I would be typing in sine minus 1 of 1 times sine 30. And you don't need to put a degrees sign because you make sure it's degrees by making sure that your calculator is on degrees mode. Close brackets, divided by 1.5, close brackets. And that will, if you're using the divide by key and brackets, you will get the right answer. Sometimes you'll get the right answer with the fraction key, but sometimes not as well, so just be careful with that. Jake,
How do you put it in certain degrees?
go shift menu. Go down to the and to choose degrees.
This has been
Very tricky.
very listen.
Very tricky.
You can't just push.
Choose it.
Okay,
Uh,
are we okay with that one?
Yes.
Example for you guys, can I rub this off?
Yeah.
Okay.
Straight up.
How much is refractive index of diamond again? Can you Google it? Is it 2.4 or something? 2.42?
Yeah, it's around that.
Yeah, I'm pretty sure.
Pretty
Nah,
sure.
it's like
Yeah,
three.
sounds alright, sounds alright. Let me just do the equations real quick.
Sin, anti-sin.
Carry the 2.
What is that?
Sorry, 2.417 to 2.4. 2.42. So
Yeah, I knew that.
N1 is
It's pretty much what I said.
Diamond.
diamond, N1 is 2.42, N2 is air, N2 is around about equal to 1.
Or not.
And I'm going to give you a couple of different angles to investigate. I want you to find out the angle of refraction if the angle of incidence is 5 degrees
want to spell diamond after my marker after yours, but let's do that.
I want you to find the angle of refraction if the angle of incidence is 20 degrees, and if you finish that and there's still any time, I want you to think about what is the maximum possible angle of incidence.
Maximum possible. Surely it's 90.
It'll be 89.999999999999999.
Or zero.
Isn't it like the angle where like it just bounces off?
Oh, you're right. Yeah. Or instead of actually like going and it just goes.
The lower you get to your wall, the more thick it gets.
Yeah, you're right. You're right.
Well, like the lower the angle, the more thick it gets.
Means more towards you.
No, like go like this. It's not moving with it, and then go like that.
So see what you can do. Calculate it for 5, calculate it for 20, and then find me the maximum possible if you can.
Do you have to memorise that equation?
So there's no equation that you ever have to memorize.
Except for all the tables, equations, and graphs from last
It's
year.
not about memorizing equations, but it's helpful to do.
When I say 30 step higher, I keep thinking it seems easier.
Can I argue?
Who's got the answer for the first one?
Not me.
Oh. I'm too slow for that.
Just 6.
No, 12.18.
Oh, so
Sorry?
1.
12.18.
12.18.
It's rounded to 2%. And the next one is 55.86.
Point.
86.
Oh, yeah, I changed it. I was going to say.
What were you about to say?
You said it was 18, you're going to look at my calculator. I'm going to do a answer. Oh, we can just use the same equation and change the...
There's a whole bunch of brackets.
You did. You're dividing everything in there. No, you do. You're dividing everything in there. It's too big actual currency. Go on.
And then the way to attack the last problem, the question of what's the maximum possible angle of incidence that causes refraction, is to think about it as what's the maximum possible angle of refraction? What's the biggest possible angle of refraction?
90 degrees.
No, because we're noticing here, it goes in at 12, it goes in at 5, comes out at 12, goes in at 20, comes out at 50. We're noticing that it's going from more dense to less dense. It's refracting away from the normal.
Stupid.
And so the way we're structuring our question is to say the maximum possible angle of refraction is 90 degrees. So theta r max is 90 degrees. Let's have a look at what that does. N1 sine theta I equals N2 sine theta r. And we want to find out what the maximum is. Theta r is 90. How much is sine of 90?
1, was
Someone slapped in. 1. Good. If you put it into your calculator, sine of 90 is 1. So we don't even care. Who cares about times by 1? Let's rewrite this. N1 sine theta I equals N2. Because sine theta r, maximum sine theta r is just 1. We're going to rearrange it to leave the theta I by itself. So sine theta I is N2 over N1. Theta I is just going to be anti-sine of N2 over N1. So the angle of incidence, the maximum possible angle of incidence, is going to be the anti-sine of N2, 1 over N1, 2.42. How much does that give us?
So we're looking for the max possible refraction.
It's 24.41.
I don't know. I think more than 24.
We're looking for the maximum one.
24.41 degrees. And this is an important thing for you to know. That angle there is what we call the critical angle. That's the maximum possible angle that we can fire light from diamond through to air. If we have our angle of incidence any bigger than that, it doesn't go through. So we call that angle, that maximum possible angle, we call the
It's not even very big.
critical angle.
That's pretty small.
It's not very big because diamonds sparkle.
Oh, that one is sparkle.
So we will come back to this critical angle. We will have a look at what it looks like next time. But for today, I have got you a convex mirror ball in a garden. And Tim was looking at it and he noticed that his reflection was really small.
Oh, how many taken?
Fucked.
Alright.